This is a handheld vacuum cleaner, and we are going to turn it into a CAD model. Our objectives were to disassemble the product and rebuild it in Autodesk Inventor, improve the handle's design using reverse engineering because we found it difficult to hold, and finally, produce a rendered 3D model for physical calculations and a 3D printed component to confirm our model's dimensions. Here's how we did it.
Firstly, we planned our workflow, deciding to focus on modeling components first, then splitting the team to complete separate tasks. For disassembly, each part was measured for major dimensions, photographed, and recorded in a registry for ease of communication between the team. Each team member then modeled their assigned parts.
This is when we split into two teams. Team A built the assembly structure. Our assembly had a few dimensional issues, so we went back to fix those. We ended up with a dimensionally accurate assembly to start 3D printing the fan cover. The 3D printed part came out dimensionally correct, so we were sure we could move on to reverse engineering the handle.
Team A created the modified handle by adding clay to the current one before going to scan. Here's where we made a mistake. Our scan didn't work on the black painted portion of the component, so we had to paint it white before scanning again. Then it worked.
Putting the scanned handle into our assembly proved a challenge. The scan came out in inches, so we had to convert to millimeters before scaling down. Another issue we had is that the internal features of the handle were not scanned, so that's one thing we would need to improve on.
We then produced drawings that would be used for manufacturing the product, focusing on adding dimensions and tolerances that improve readability.
Finally, we created a rendered model by applying materials and measured the mass, surface area, and center of gravity to ensure the modified vacuum cleaner would be user-friendly.